Hello everyone. So today I'm going to provide you with the notes of one of the important topics of chemistry, that is periodic table. So directly coming on to the topic, we'll discuss about diagonal relationship. Lithium, magnesium, and beryllium and aluminium. These elements exhibit diagonal relationship due to similar size and similar radius to charge ratio. Shielding effect or screening effect. Effective nuclear charge Z effective is inversely proportional to shielding effect. Order of screening effect in a given shell is given as S greater than P greater than D greater than F only for a particular shell. Atomic and ionic radius. So here we'll discuss about types of radii. Covalent radii. Let us take an example of H atom here. Covalent radius is equal to half the distance between HH bond. Metallic radii is defined for certain metals. Metallic radius is half the distance between the metal-metal bond. Van der Waals radii. Van der Waals radius is equal to half the distance of HH bond. H atom is only taken for reference here. So Van der Waals radius is the greatest among all three radii. Trends of atomic radii in periodic table. In a period left to right, radius of atom decreases, and in a group top to bottom, radius increases. We'll discuss about exceptions. On going from fluorine to neon, there is a sudden increase in the radius because for neon only van der Waals radii is defined, and we already know that van der Waals radius is the greatest among all the three radii. And in P block there is an exception between gallium and aluminium because of the poor shielding effect of inner d orbitals. In D block, scandium, radium and lanthanum follow the normal trend, but for 3D, 4D and 5D series we have 4D and 5D series have almost equal screening effect due to lanthanoid contraction. Now we'll discuss about ionization energy. The energy required to remove an electron from loosely bonded gaseous state is known as its ionization energy. Ionization energy is always positive, and do remember that second and third ionization energies are always greater than the first ionization energy. Factors affecting ionization energy. Ionization energy is directly proportional to Z effective and it's inversely proportional to atomic size. It also depends on from which subshell the electron is being removed. That is, the more nearer the subshell is to the nucleus, the harder will it be to remove the electron. That is, more ionization energy will be required to remove the electron from that subshell. Now we'll discuss about the trends of ionization energy in the periodic table. In a period left to right, ionization energy increases. In a group top to bottom, ionization energy decreases. Ionization energy can be linked to the size factor. Now these are the following exceptions of ionization energy. Kindly go through them. Ionic radii. Cations are always smaller than their corresponding parent atom, and anions are always larger than their parent atom. For isoelectronic species, that is, the species having same number of electrons, size is inversely proportional to the nuclear charge. Electron affinity or electron gain enthalpy. Trend of electron affinity. Left to right in a period, electron affinity increases, and top to bottom in a group, electron affinity decreases. And note, second electron affinity is always positive. Chlorine has the highest electron gain enthalpy. Exception. Due to small size of second period elements, the incoming electrons experiences more repulsion as compared to third period elements. Electron gain enthalpy order. Chlorine, fluorine, bromine, iodine, and sulfur, selenium, tellurium, oxygen. Electronegativity. The tendency of an atom to attract the shared pair of electrons in a covalent bond is known as its electronegativity. It is a relative term, and note it has no unit. Factors affecting electronegativity. It is directly proportional to Z effective directly proportional to positive charge and is also directly proportional to the percentage S character. General trend of electronegativity. In the periodic table, left to right in a period, electronegativity increases. Top to bottom in a group, electronegativity decreases. On the Mulliken scale, electronegativity can be defined as ionization energy plus electron affinity upon 2. And do remember, fluorine is the most electronegative element in the periodic table.